Hello everyone, and welcome to our latest CloudScape tutorial. In this video, we'll be looking at some of the ways that we can maximize quality and visual effects to get a truly cinematic experience out of our asset. To start us off, we have a blank Unreal Engine 5.1 project that we have created and added CloudScape to. So next up, we're just going to be opening our supercell map. From the start, we could see that some of our clouds look quite soft. The reason they appear so is because of some of our optimization settings that we have right off the bat, but these can be easily disabled, so let's just do that right now. So for starters, we can select our CloudScape base actor, and let's just lock it in and see exactly what's happening, because right now, if we were to zoom in, we could see that our clouds have this sort of edge to them, and this is basically our stop transmittance threshold value over here now. What this does is basically tells the cloud tracing algorithm that past a certain point, treat the clouds as basically a solid object. Now, if we set this to a really high number, like say 1, our clouds will basically become solid voxels and look pretty terrible. Now, this is pretty efficient to render, but they don't look great at all. So the default value of 0.5 is pretty good. Now, we could set this outright to 0 and get this really nice and soft transition, but this can sometimes have quite a high impact on performance. So a value of something really low like 0.001 or maybe something a little higher, as long as we don't see that edge, can be quite good. Next up, we can open our CloudScape Cloud Draw material, and this is basically where we can control all of our effects of the clouds and the way they get rendered. So let's get back to a regular sort of field of view. And to start us off, we have our cloud texture MIP level. And this basically controls how sharp the volumetric cloud texture is. Now we've set this to 1 because a lot of our detail is actually driven through our noise. For example, we could set this to 0 and see that our clouds did become a bit sharper, but not noticeably. And this does have an impact on performance. So generally we tend to leave this at around 1, but right now, because we're maximizing on quality, let's set it to 0. And now, how about those details? Well, if we want to increase them, we can set up our noise. Now we could multiply our noise distortion by 2 and see that we're getting a lot more sort of details, little wisps, and we can control the way our noise is done, whether it's more wispy or more billowy, depending on what we want. Probably increase it, and we can also increase the scale of our noise. We could do this in specific axes or overall in general. So this is something that we could play around with quite a while. But generally, too strong values tend to lose out on the main shape of the clouds. So maybe something around 3, 2, 3 was good, and 5, just so we have this extra little bit of detail going on around here. Next up, we have something that we call efficiency, and this basically tells the cloud tracer that past a certain point, our cloud texture is transparent. So let's just zoom in again and see exactly what this does. Now, this kind of works by sort of trimming away certain values from our cloud tracer. So if we set this to 0, you can see that our clouds became ever so slightly more transparent. And if we start to increase it, we could see that this is we can see that we're getting this sort of a sharp transition. We could actually sharpen up some of our details with this. Now, the downside is that if we were to zoom out, this does also erode some of our other clouds. For example, this sort of wispy detail over here is quite sensitive to this setting. So remove it. So at a value of 4, we can almost lose this particular CloudScape actor completely. Now we can bring some of this back by selecting our base, hitting live sky, so we can edit these, and selecting the cloud actor in particular, should be this one, and we can bump up its density. Whoops, we have it locked up here, so let's just select it, and there we go. We just had to increase it a little bit more past the threshold at which we sort of cut clouds away. And right now we have quite a cool effect, almost painterly-like. So yeah, it's just something to play around with. We can increase it a bit more and yeah, have this sort of a really cool looking sky, even if it's a bit too sharp and too unrealistic. So right now, just to demonstrate the maximum sort of visual effects that we can get from this, we're not going to set it outright to 0, but again to maybe something like 0.01, just so it's there, it's doing its thing, but just so there is no visual impact. And the quickest way in this scene to check it out is around the edges where it meets the sky. And basically, yeah, we don't have an edge. We have a nice smooth transition. We do have a little bit of noise coming around here, but we'll be tackling these next up. So just to sum this up, these are basically the quality settings on the side of CloudScape that we have sort of built in. Now, what we're going to go over next are some of the C variables that come with Unreal Engine in regards to cloud rendering. And these basically will apply to pretty much any volumetric cloud system out there. Whether it's your own custom sky that you've built with the vanilla Unreal Engine or another third party that also uses the volumetric cloud component, these basically control all of these. So yeah. And without further ado, let's dive in a bit further down our tutorial. So starting off, we're just going to rotate our light here, just so we get something, a few more highlights to work with, like this. And straight off the bat, you could see that there is a little bit of ghosting going on over here. And if we were to select our base actor, value of this, nope, we'll have to set our efficiency to 1 or maybe 2. Now, this is quite cool, as you could see that in this case, we're technically making things easier to run while also getting rid of this sort of outline that we have here on our clouds. So a default value of something really low like 0 will not necessarily bring out the best in quality. So sometimes these are up for interpretation. So in this case, yeah, a value of 1 actually made things better. A value of 2, a little too sharp, but let's just go for middle ground. So we do have a little bit of sharpness. Let's say that this is the kind of look that we're going for in this case. So about them C variables now, a very important aspect is what is the driver behind the volumetric clouds? Well, that is the volumetric render target. And these can actually have a huge impact on the visuals. So if we go to our volumetric render target, we have a number of options, and the most important one is mode. Now the default one is 0, and as you can see, nothing changed. Whoops. Then we could go to something like 1, and you could see that the noise here changed quite significantly. Now these sort of changed the way that the original cloud sort of buffer is being upscaled and processed. 2 is probably the sharpest one, but you could see the noise over here. Don't worry, we'll take care of that in a bit later. But overall, in terms of detail, 1 and 2 are night and day. Now, each of these modes have their own sort of advantages and disadvantages. Now, while 2 does give you the highest sort of quality, now if we were to zoom in, it does come up with a bit of a obvious sort of limitation that, to be fair, 99% of people using clouds will probably not run into, and that is it doesn't have great or any really sorting when it comes to objects that intersect the cloud. So if we were to take this cube and make it massive, like 1 kilometer wide, and put it up against the sky, you could see that the cube will always render in front of it, in front of the clouds, no matter what. Now, this won't be too important because generally near the horizon, clouds will be obscured by mountains and stuff. But in case you want something intersecting or clouds wrapping around a mountain, you'll want to have a render target mode of either 0, just so we get this really nice blend, or 1. Now, if you recall previously from the demo, 1 looked a little bit sharper and also has this blending. It's also the heaviest one we found to sort of render. But in this case, because we want a really nice sky of the sharpest possible quality, we're going to go with render target 2. We're not really going to have anything intersecting it in this case. So let's just zoom in on this sort of a problematic area. And next up, after render target mode, we have render target upscaling mode, and these come in a few quite a few options. So 0 will remove upscaling, and this can generally make things look quite noisy and blocky. You have upscaling mode 1. Now, these don't really have too much of an effect on when we're using render target mode 2. So right now, let's go back to 0 and set the upscaling mode to 0. And you could see that things became a bit noisier than before. You could set it to 1, and you could see that the noise sort of became blurrier, but it's still there. In general, in this part, we encourage experimentation and mixing and matching render target modes with upscaling modes just to see what works best for your scenario. 3 and 4. Now, these basically differ in the way that the noise gets applied and calculated. But again, we will be using render target mode 2 in this case, and yeah, that sort of gives us the best results. Now, something else that you should know is that when using render target mode 2, you could go to r.volumetric clouds and HBZ culling, and you could set this to 0 because this function basically tells if there's a opaque object in front of the clouds, basically don't trace the clouds behind it. And since render target mode 2 already doesn't do that, it doesn't sort in front or behind objects, we can disable this as well. There is another limitation to using this render target mode, and that is if we go to high quality aerial perspective and set this to 1, the clouds will basically become all kind of white and pale. It really doesn't like this setting. So if you're planning on using it, high quality aerial perspective should be 0. So next up, let's look at some of the things we could do about the noise. So let's zoom in on our area and basically where everything is going pretty badly in terms of noise. So something that we could do is select our CloudScape base actor like so. We're gonna select expand view sample count and set this value to 4,000 is generally a good one. And what this does is it allows us to push this number, the view sample count scale, past the regular limitation of around 12, I believe, or 8. Now, a default value of 5 kind of doesn't give us enough samples to cover these sort of translucent areas. So we can go with something like 10. And you could see that the noise just disappeared by quite a bit. And if we go to something like 15, there's an improvement there as well. Something like 20, better again. Now, increasing this value has a very high impact on performance, so keep it as low as possible, but for this case, we could go for something as high as even 40. Now, you can't just increase it until you see until you stop seeing a difference, and realistically, maybe around 20 is where this stopped for this particular scene. And right now, we're getting some really nice sharp cloud details. All the wisps and stuff are looking pretty great over here with some of our animated noise texture coming through. So let's go for a different scenario right now. If we were to have a very shiny surface, something like an ocean or a lake or a huge metallic plate. So right now, let's just create a very quick sort of metallic looking material. We're not going to need this anymore. Base color 1. It's going to be very metallic. It's going to be 0 roughness, and that's basically it. We're going to hit apply, and we're going to basically apply this material to our floor here. And oh god, our sky looks absolutely terrible. What's going on here? Well, let's look at our post-processing volume material and see what we're doing about reflections. Our reflection method is lumen, although in this particular project we've also enabled ray tracing. So if we were to go to standalone ray traced, we're getting a little bit better of the fog, but our clouds just look terrible as well. We kind of have this weird line here. So let's just deal with the line. Now if we were to go to fog, exponential height fog, and I believe the setting here was just kind of increase the start distance. And there we go. We have a nice smooth transition. We haven't really lost anything on the fog part, but our reflections still look terrible. Now, why is this? Well, clouds are kind of already done via ray tracing, or ray marching rather, a very complex material function sort of thing that's kind of behind the scenes. And the way that actually ray tracing our lumen reflections handle clouds and sky is that they're driven by the skylight that we have over here. Now our cube map resolution is 128 right now, and the real-time capture is on, and this is why basically we get this sort of blocky movement. If we were to disable real-time capture, this kind of looks better as it's not jittering, but it's also not accurate. So to start us off, we can increase our cube map resolution to 512 and see that things look pretty sharp but still really awful. Now generally, since we're trying to get the maximum quality out of things, let's set this to a 1K texture. So how do we improve the appearance of clouds here? Well, we need to select our CloudScape base actor, and we need to increase the reflection sample count, because right now it's 1, and we can lower it and see that this is basically what's driving the appearance here. So let's go to something like 10 or 8, but we could see that for some reason our clouds basically became black. Well, this is because we also need to increase the shadow reflection sample count. So let's just set that to 10 as well, and we could see that things aren't looking quite the way we expected them to. Well, this is because right now there is a weird quirk that setting the skylight intensity scale to something other than 1 will actually set it to 1, but in the reflections they basically will not align properly with what is actually above ground. So if you do want to lower the sky intensity, you should either lower the brightness of the directional light or possibly tweak the atmospheric sky atmosphere actor. That's the one. And right now we could see that, well, it's looking pretty close, but still not as close as we'd like them to. It's not a perfect mirror. So let's just log down our CloudScape base actor, and we're gonna go into our R volumetric cloud, and we're gonna look for shadow reflection sample count maximum. We're gonna set this to 4000, and next up we're gonna go volumetric clouds, reflection ray sample count. Oh no, that's shadow again. There we go, reflection ray max sample count, and set this to 4000 as well. You could get away with using different values, but these sort of give us the maximum freedom. So basically changing those C variables allow us to edit these values in our CloudScape actor past the value of 10. So for example, reflection sample count to 10, we could go something like 20. And you could see right now that near the horizon over here, our clouds look pretty good. The issue comes like near our, I guess not zenith, but when we look straight down, we're getting a bit more of this sort of layering effect. So 20 is still too low. Maybe we could go with 30, 40, 50. I think 50 is a pretty good step. Now we really need to zoom in to see the sort of issues that we're having over here. And yeah, pretty much we have a really good looking reflection. Our frame rate is really low, but again, this is sort of for production sort of environment. Now we could also look at our shadow reflection sample count. Maybe something like 20 will also improve the details. But again, it sort of depends on how much of a visual impact this will have in your scene. So 20 again will sort of fix things. And right now, yeah, this is pretty good. Now we're seeing some sort of blurring over here, and this is because, well, of motion blur. So r dot motion blur quality, we're outright disabling it, and you can see that our clouds are looking pretty good. And right now we basically have this really perfect mirror with ray tracing on, and yeah, it's looking pretty good. Now the cool thing is that since we are using ray tracing, that means we can have some really nice reflections on all sorts of objects. For example, if we drop a sphere into our scene and sort of focus around that and apply our shiny material, you can see that we're getting a really nice representation of the sky as well. But we're not getting our floor. Now this is a sort of standard ray tracing parameter, but we're just going to go over it here super quickly. We're going to go to our post-process actor here and look for reflections. And since we are using standalone ray traced reflections, maximum bounces, we can set this to 2. And now we could see that our sphere reflects the floor, but that's the second bounce. Now for the third bounce, we could see that the floor basically is not reflecting the second bounce from the sphere, and the sphere still registers as there's like a black shadow. So we could go to 3 bounces, and now we could see that the sphere with its reflection is also seen in the floor here. But again, there's like a little bit of a hole here, so we could set this to 4. And this is pretty much the part where we're getting some really diminishing returns in terms of quality. So we wouldn't really recommend it going past 4, but maybe you could try for something like 6, just to clear up those very few last pixels here. So yeah, hopefully what we've just gone over is a really helpful guide on how you can get the most out of your clouds, get them looking nice and sharp for those cinematic projects. And yeah, so yeah, just as a final note to go over how we sort of created the image that we kind of settled on for our thumbnail. We kind of used this setup that we had when we left off the sort of regular tutorial time. And what we did was go back to our CloudScape actor. We changed the noise texture that we're using to distort the clouds to T noise V6. This comes with CloudScape. Next up, we changed the cloud scale to 0.5, 0.5, and 2, just so it sort of flattens out the clouds and spreads them out a bit more. We set the noise contrast to 0.5 and distortion to 0.05. In terms of cloud albedo, because we wanted to have a nice sort of sunset scene, we set it to this sort of kind of bluish color. And color extinction, we kind of didn't really change anything on it. And next up, we kind of set the efficiency to 5, and this sort of gave us this sharper looking cloud. So if we set that to 0, you see we get this smooth kind of clouds, and with 5, yeah, it's kind of like what we're getting. Maybe you could go with something like 8. Whoops, too high. But 5 is a kind of nice middle ground that you kind of decided to use. Next up, in terms of CloudScape base, one thing that we changed is set our use per sample atmospheric light transmission. With it off, you kind of don't get this sort of nice effect. You get a kind of harsher shadows. We set our shadow tracing distance to something quite low now. This isn't entirely accurate, but in terms of artistic control, it allows you to do some really nice looking things, like sort of just make the shadows look a bit softer on the clouds. And having this low allows you to also have a lower shadow view sample count. So right now we're at 1. This might actually be a bit too high for what we're trying to do. So as you could see, just lowering it to 0. Okay, at 2 it does have a difference. At 4 it kind of does. So 5, 4, 5, kind of like that. So this will again gain you performance while having 0 change in visual fidelity. Next up, just for the sake of transparency, we've also rotated our directional light to these coordinates. So it's kind of just like setting up. This is again the default supercell map. That's like our tornado. So the light is kind of going down. Haven't really changed the color of the lights. Let's see if we can get some nicer looking colors. Nothing really too fancy. Next up, you may have noticed that while making changes, our reflections don't really change, and that is because we have set our skylight to not capture in real time. This gives you a huge boost in performance, and realistically, we have such a subtle animation on our clouds that it's not really worth it on our mirror. So as you can see, we're getting some really nice sharp details and wisps on all of our clouds. So yeah, as another sort of quick bonus tidbit, here's like a really cool effect that you can do with your clouds, that if you were just to enable this sort of setting, volumetric cloud, enable local light sampling, set that to 1. So this is going to have a huge impact on your performance, but what you could do now is add in local light to your cloud. So for example, something like a point light that we can just place here, and we're going to have to set the light intensity to something really high, but you could see it's affecting the clouds. So there you have it. You can have local lights interacting with your clouds. You just really need to bump up the intensity and the attenuation radius. So maybe something even a little further. So yeah, basically like a really cool explosion of some sort, or lightning. And as a final note, if the sort of FFT bloom coming from the point lights is bothering you as much as it's bothering me, well, something you could do is just select the 2 point lights and set their specular scale to 0. And then boom, reflections and sky are perfect